In this video, I'm going to demonstrate the Epsilon driver for Simulink. And to do this, I will try to programmatically recreate one of Simulink's built-in example models. So if we start Simulink, one of the built-in templates is this simple simulation. Right. So this contains a sine wave which feeds into a gain, then into a saturation, and eventually we have a scope that allows us to see how these signals evolve over time. So if we run this simulation and then we double click on the scope node, we can see how these three different signals evolve over time. So what I'm going to do in this demo is I'm going to try to create the same model but programmatically using Epsilon's EOL and the Simulink driver. So I no longer need this. I can go back to my Eclipse and create a new project to start with. And inside the project, I need to create a new EOL file, which I call simple simulation.eol. And I will copy and paste some code that I've written before. Right. So in this program, what we do is first of all we create the four elements, the four nodes of the Simulink diagram, plus this this bus that connects all of them to the scope. The next step is to set the positions of these nodes on the diagram so that they look nice. Set some of their properties, and then finally link them up together. So we want the sine wave to link to feed into the gain to feed into the saturation, and so on and so forth. Right, so we can now run this program, and in order to do this, we need to create a new run configuration. It's an EOL program, and we need to specify that it operates on a Simulink model. So any name is fine here. Now the Simulink model does not exist yet. We're going to create it through this program. So here what I'm going to do is I'm going to provide a file name of a file that does not exist yet, right? Simulink files have an SLX suffix. So the model that I'm going to create is going to be put in this simple simulation.slx file. And I don't want to read this file because it doesn't exist when I start my program, but I want to save it when I'm done. Okay, and that's all done. So I can run the program. And we can see the Simulink window popping up. And now all the different elements are created and are linked up. So as I did before, I can now run this simulation. This is a complete simulation. It's an exact copy of the built-in example. So now if I double click the scope, the window that visualizes the signals over time pops up.